Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Today we're going to discuss on safety in railway operation. So this is the chapter 1 in signaling and communication course. Okay. So first let's look at the definition of safety. So safety is defined as a property of a system which does not in any way endanger neither persons nor its environment. So in railway system context, it means that railway system does not endanger atau membahayakan either person manusia ataupun environment kawasan sekeliling sistem tersebut. And another definition is a removal of unacceptable risks. So we already know that railway system is a system affected by various sophisticated influence. So apa itu influence dia? Contohnya adalah human error, sebab kita ada staff ataupun pekerja manusia, bukan fully robotics, although most of the urban train is fully automated. Tapi kita still ada engineer manusia juga, kita ada dispatcher still manusia juga. And then we also need to look into the unforeseen failure. Failure ni means from the mechanical or electrical punya system failure lah, which is unforeseen, yang tidak dapat dijangka. Dan kita kena lihat juga the negative influence daripada situation yang kita tak dapat jangka, contohnya banjir, flood or earthquake. So those influence we need to look into to make sure the safety in the railway operation. So basically there are three safety elements that we need to know. So safety of a railway system is dependent on a balance of following three elements. The first one is the man or human, second is the machine, and third is the environment. So neglecting one of the elements may cause a system imbalance, menyebabkan sistem ni tak akan balance, which result a negative externality and thus interrupt the operation execution. So kita kena make sure these three element berada dalam keadaan balance dan dengan antara satu sama lain. The goal of optimization of ergatic system, man, machine and environment is to ensure well-being of humans and prevent any injuries caused by accidents. So what is the ergatic system is this one, figure 1 here, which consists of human, machine and environment, and it is overlapping with each others. So dalam railway system ni kita tak boleh neglect one any of these three element here lah. So it means that we need to balance our priority on these three element. Kita tak boleh tengok on the machine only, kita buat maintenance only tanpa kita lihat human factor or environment factor. So we need to look at these three element in a balanced way lah. Okay. So railway personnel perform various type of tasks during their work environment. So some of these tasks are more prone to human error than others. So in railway system that personnel or staff basically they have their own tasks. Engineer doing their engineering punya task, dispatcher ada dia punya task sendiri, and then apa lagi, train driver ada dia punya task sendiri. So there are many areas for the occurrence of human error in rail operation, and there are three type three typical ones are as follow lah. Yang biasanya akan berlaku error basically is in the signal passing, train speed and also signaling or dispatching. So these three punya task is basically the most the most occurrence lah to have a human error, right? Okay. So kita tengoklah setiap task ni lah. So let's look at the first task which is the signal passing. So signal passing ni basically for the fixed block punya signaling lah. Di mana kita ada train driver, then they have a signal or signal aspect lah untuk tunjuk whether they have to slow down or to stop or to go with full speed lah, something like that. So this is very important area because train passing a signal displaying a stop is a very dangerous occurrence because it can lead to an immediate conflict with another train or trains lah. So means that if a signal show a red light or stop sign, so you need to stop the train to be stopped because the block in front should be occupied lah with another train. So if the train didn't stop, it means that it's going to be a rear end collision. Okay. So this situation is often referred to as signal pass at danger, SPAD lah, and in the past its occurrence has been quite frequent lah. So dia kata sebelum ni sebab kebanyakan sebelum ni menggunakan fixed signaling punya method, tapi sekarang mostly adalah moving blocks lah, which all the train is moving automatically. So if you look at table 6.1, these are some of the causes of the occurrence of SPAD event lah. First, failure to see signal because of poor visibility, misjudging the brake effectiveness, maybe due to rain or flood or or bad weather, oversight or disregard to a signal, overspeeding, and then disregard the braking performance and warning signal distance, driver fall asleep or is unconscious, or maybe the driver using a phone and did not see the signal, misunderstanding or of signal aspect. So if you learn about the signal aspect, there's a lot of apa dipanggil code lah dalam signal aspect ni. For example, for Canada punya signal aspect, they have 43 different code, different combination of color, whether what you need to do lah if you see a double yellow or single red or something like that. And then lastly, misjudging of which signal apply to train in question. Okay. So let's look into the train speed. This is another area that has resulted in numerous accidents because of failure of the train to reduce train speed as per specific for the route in question. So it's like overspeeding. Okay. So they basically there are three types of speed restriction. So they have a permanent speed restriction, they have a temporary or emergency speed restriction, and lastly is the conditional speed restriction, where the train driver need to follow this kind of speed restriction lah, based on where the route is. The permanent speed restriction are imposed because of track curves or some existing infrastructure condition on a particular section in the route or the track. The temporary or emergency speed restriction are imposed because of track maintenance work or temporary track deficiency. And lastly is the conditional speed restriction. imposed because of the train route setting at a junction or station and the signaling aspect displayed in that regard. And lastly, the signaling or dispatching. So in the past, many railway accidents have occurred in this area because of error made by signaler or dispatcher. Right? So right now, if we have OCC, so we don't have any signalman but a dispatcher in OCC lah. So for fully automated train, basically the route is already been configured early in the morning, so the dispatcher just monitor it. But however, if there's a system breakdown, for example, what happened in Keranjaya line collision, there's a problem with the system where the train need to drive manually. So the dispatcher what we say, memainkan peranan yang penting lah untuk memandu arah, menunjuk arah basically train driver ataupun hostler tersebut lah untuk bergerak ke tempat yang sepatutnya dituju. Dan sepatutnya tidak berlaku miscommunication lah between these two lah, two personnel. Fortunately, with the application of modern technical devices, the occurrence of human error in this area has been reduced significantly. So this is another list lah of some tasks performed by railway personnel that prone to serious human error. So we have personnel maintaining the concerned vehicle, so we need to make sure that the maintenance is correctly done. Station foreman receiving the train into the railway station. So ini basically dulu punya cerita lah but mostly we have a dispatcher yang automatic train lah. And then railway personnel maintaining the track. So track maintenance is also quite important. Sebab apa? Sebab with good if the track is not maintained well, it might we call it trail boleh berlaku trail derailment lah orang cakap okay, trail derailment due to apa, uneven or bad maintenance track lah. Railway personnel loading the wagon. So basically untuk wagon means I think about the cargo cargo. So kita kena pastikan barang dalam kargo diletakkan dengan seimbang lah supaya kalau dekat curve dia tak terbalik ke kan, macam tu lah. Switching person controlling the point, so ini semua automatic. Railway personnel maintaining the track system and device. Engine driver driving the train, so this also we have a electric train, mostly electrified train. So if it's a diesel train, so we have to look into it. Station foreman or supervisor dispatching the train from the railway station, ini pun tak ada lah okay. So we have discussed the first element, which is the man or human. So we look into the second element, which is the machine. So the term machine means railway vehicle which may under certain circumstances disrupt the functionality of the railway system. So the circumstances may be bad technical condition, derailment of vehicle and others. So this is about the machine. So in railway system, we have to look into few what we call few system lah, subsystem lah kita panggil first is for example signaling and communication. We have to look into the track punya system, and we have to look at the rolling stocks, right? And we also look into the electrification. So this we can say that those subsystem is the machine lah. So the safety of this three element is important. This four element is important to make sure the safety of the safety of the person or passenger or personnel, and also the environment. And lastly, we're going to look into the environment element. So environment is another element of railway system which directly influence safety of the system. So railway vehicle exists in certain environment in which other necessary machine and devices are used and various activity are performed. So kita kena look into the environments. So mostly environment ni kita boleh cakap for example earthquake, flood. So this is the element in the environment lah, which influence the safety of the railway system. So we have to look into it. So for example we look into the case study in Japan where they have a major earthquake in Japan here. So this is the taburan earthquake, major earthquake that happened in Japan from 1985 to 1995. And if you look at this figure 1 here, the current safety status of GR is this, the company that operates the train. So if you look at this, the accident is reduced from this is the accident and this is train per kilometer lah. So if the accident, it means that it reduced quite a lot from 1987 to 2001. So basically Japan already know that their country banyak berlaku gempa bumi. So what they did is they try to look into this safety aspect lah. Contohnya dia buat train line tu bukan berada dalam kawasan gempa bumi if possible, and also they have a sensor of prediction on how to know when the earthquake is happen. So apabila berlaku gempa bumi, the train will be asked to stop lah. If there's a driver, they will ask the train to stop for automatic. So dia akan automatically berhentikan train tersebut lah. Dan selepas gempa bumi, baru dia berjalan kembali lah. Train operate as usual. So that's how Japan did counter the earthquake lah. Okay, so that's why the accident is reduced every year. They use technology to make sure the safety of the railway system, passenger, and also the environment lah. So other than that, they also have a prediction on the rainfall and also ground punya, what we call it, ground saturation measurement, so that they know when they need to do the maintenance on the slope here near the rail tracks. So dia menggunakan sensors lah, sensor dan teknologi lah untuk detect and predicts all the environmental disaster yang mungkin akan berlaku. So even they have a GPS tracker for their worker to make sure that the train is not going to hit any worker on the track doing maintenance or anything. Okay. So this is one example where flooding causes train derailment in 2015. So if you look at this video in YouTube, flooding caused train derailment in 2050, if I'm not mistaken, is in Australia. So basically, um, we have to look into the environment element lah, to make sure the safety of uh, railway system. Okay. Okay, let's continue with the component of the railway safety system. So safety of a railway system is characterized by three basic components. So the first thing is the safety indicator, the second is the safety goals, and the third is the safety method. So safety indicator are information regarding the railway system safety, which allows comparing the system safety level to the safety goal. So they represent the parameters defining the railway safety level. And safety indicator comprise the system element. Example of the indicator are serious accident where life were lost, and etc. Okay. So based on the mentioned indicators, the safety goals are set. So safety goal represents a minimum safety level expressed by acceptable risks which have to be reached by all elements of the railway system. So basically is a minimum safety level that we need to achieve. That's is the safety goal. The goal is to maintain the safety of the whole system via minimization of risks. So for safety method, introduce a harmonized approach to risk evaluation. So which is necessary for the integrated railway space. So this method basically serve a purpose of describing ways to assess the safety level, reach the safety goal, and observe other requirements regarding the railway system. This is your first assignment for chapter 1, risk in the railway system. So I would like you to find out the cause and effect on the disturbance in the railway system safety, and the discussion should be specifically on the human error. And I would like you to use Ishikawa diagram to find out the cause and effect of the disturbance. So Ishikawa diagram is basically a diagram that shows the cause of an event and is often used in manufacturing and product development to outline the different steps in process, demonstrate where the quality control issue might arise, and also try to determine which resources are required at a specific time. So if you look at the slide here, this is an example of the Ishikawa diagram in the disturbance of the railway. So it has, so it's like tulang ikan. Dia ada tulang ikan, dia ada kepala, dia ada tulang. So usually at the bone here, tulang here is the cause of the disturbance, and at the end of the bone ni basically is the effect yang daripada sebab ni lah. Contohnya human error on repair of rail. So risk tu kepada siapa? Kepada employees or kepada passengers, some sort like that. Okay, but this is an example. For your assignment, you need to focus or specifically specify on the human error, the risk to the human, and also the cause by the human. Okay. Other than human and environment safety, we also need to look into the network or data security, which is the safety of the whole system, signaling system. So if you look at these figures or diagram, it's basically is a network of I would say is I think it's a Kelana Jaya or Ampang Line network lah. So this is just an example. If you look at this at the bottom here is the untrusted network, and we have a trusted network after the firewall of this equipment as a firewall. So we need to identify basically the trusted and the untrusted network, also the main and the primary and the secondary backbones. So in wayside network, there are three components for data communication system. So we have the OCC, or at a station using LAN. So usually you use a switch and a server to connect between the workstation, server and everything. And then we also have a trusted backbone which is connected to the multiple what we call it OCC, zone controller or region controller. So mostly they have two trusted backbone for backup, and also primary and also secondary. And mostly for a long communication, they use a single mode fiber backbone, class 1 and class 2. So class 1 is the trusted backbone for train control, and class 2 for the trusted backbone for train supervision. And lastly, for the untrusted backbone, which is the wired the wireless communication. So basically, for this architecture, we will discuss it more on the architecture side lah. Okay. And this is the example for TELUS architecture. So we have on top is the central, which is the OCC, and then we have the wayside equipment. Consists of zone controller or region controller. We have the SD bank for security data bank as a firewall between the trusted and the untrusted network. And this is the untrusted network, where the main component is the wireless radio unit. So it is installed at near the track for communication between zone controller, OCC, and to the train lah, VOBC, vehicle onboard controller. So WRU is at the wayside and MRU is in the train. So it is connected wirelessly lah. Okay. Other than that, it is fiber optic. It's either single core or multi-core fiber optic. Depends on the application. Okay, and then we have the on board punya equipment, VOBC, MRU and TOD. So this is an example for the Ampang line punya train. So control table also is an important key point for the safety, because it is related to interlocking. So control table are the functional specification for railway signaling interlocking. They have an important role in the signaling design process, since they act as an agreement between the rail administration and the train operators on when move will be permitted on the track layout. So control table contain the key functional safety requirement for the interlocking. A control table is a structured or tabulated presentation of a rule govern routes setting on a railway track layout. Okay. So in full automatic train or urban city train, mostly control table is already been ataupun kita panggil routing table lah, routing punya list selalunya akan diupload lah oleh dispatcher, oleh OCC pada waktu pagi sebelum train bergerak and then after that the train will automatically follow the routing table lah, ataupun dia punya control table ni. So those list or table it will be uploaded to all the ZXs atau zone controller ataupun region controller lah. Okay. So because the zone control or region controller yang akan bagi movement authority to the train in their region ataupun in their zones. Okay. So in each train lines, macam Kelana Jaya, Ampang lines, Sungai Buloh lines, they have their own rule books lah. So they all have their own rule books on the network maintenance regulation, NMR dipanggil. So each rule book ni, each line basically saya rasa berbeza lah dia punya proses dia. But secara general, I would say it's the same lah. So for example, in Ampang line, they have their own rule book. For example, NMR 1A, 1B, 1C. So it depends on, this is basically for the track inspection at grid or sidewalk or the center walk. And then they have the NMR2 and NMR3 for track maintenance purposes. So NMR2 means that the third rail is turned off, where the maintenance staff need to work in the operating gauge, and number 3 might be working for the outside operating gauge, for example macam orang potong rumput kan. So it depends on basically for this NMR basically is to ensure the safety of the rail personnel or railway staff lah. Okay. And other than that, there's a NMR4, NMR5. NMR5 is in depot where the third rail is turned off, and NMR4 is working from outside to inside operating gauge. At grid, for example, orang potong rumput nak masuk ke dalam operating gauge sebentar, so they have to apply for NMR4 lah. Okay. So this is the general standard for the operating gauge lah. If someone say the operating gauge, usually the standard width dia adalah daripada tengah ni ke tepi adalah 2.4 meters, and the height is around 4.05 meters. Okay. Okay, I think that's all from me for this chapter 1. So we'll meet again in chapter 2 lah. Okay. Thank you. Assalamualaikum.